section 3.9, energy and chemical and physical change. I'm going to apologize again for these slides. I haven't had time to edit them like I'd like, and so there's a lot of stuff on here. It's all good stuff, but I'm not going to necessarily read all of it to you. I'm going to try to just share the big ideas with you. So energy drives the behavior of matter. And the principle here is up here. There we go. Systems with high potential energy have a tendency to change in a way that lowers their potential energy. Things go to lower potential energy. If I hold my pen up here, I've done work to lift it up against gravity, and now it's sitting up here, it has higher potential energy than it did before. If I let go of it, it's going to go to lower potential energy. Things go to the lowest energy state. I have a couple of teenage boys, well, one's a former teenage boy, he's 20 now. They tend to go to the lowest potential energy state, which is flat out in their bed. You know, maybe watching movies on their phone or whatever, but they'd like to be horizontal. Low energy, right? And occasionally they get up and they go to football practice and they do great things. They go to work and they come back and they go to low energy state. Okay, everything in nature tends to do that. Things fall down, lower potential energy. Some things have a great deal of energy stored inside of them, and TNT is one of them. TNT is an explosive. Trinitrotoluene is its chemical name. It's got a great deal of potential energy stored in it. When you ignite that, it explodes, and then it has less potential energy. So we have two words that we use to describe energy in chemical changes and in physical changes. One is exothermic. Exothermic. And the other is endothermic. So again, it's helpful, It's helpful to have a little bit of an understanding of what these prefixes mean. So exo is like the word exit. When you exit the building, where do you go? You go out, you leave. The prefix endo is a little bit like the word in, going in. So we have exo and endo. Thermic relates to thermal energy, refers to energy going in or out. And we take the perspective of the system, the particular part of the universe that we're looking at. So here we show a graph, and we show rising energy going up. In an exothermic reaction, the reactants start out with high energy, and after the reaction, the products are at low energy. Looking at the reactants, where has the energy gone? Did it come into them or did it leave? It left. Exothermic, the energy went out. Down here is an example of an endothermic reaction. Again, we're graphing energy being higher. Here we have the reactants starting at a low energy state. They absorb energy, and the products are at a higher energy state. So this is endothermic, the energy is coming in. Any questions about that? Exothermic and endothermic changes. So here's, yes, question.
Would a battery be endothermic?
A battery being charged is endothermic. A battery powering something else, the battery process would be exothermic. The energy can come in, the energy can go out. And remember, conservation of energy is not created or destroyed, it's only moved around. So if the energy comes in, it has to go out from something else. And so that's why we have to look at what's gaining, what's losing. And so we tend to talk about the system and the surroundings. The system is what we're looking at. The surroundings is the rest of the universe. Surroundings are always very, very large. So we should be able to do things like this. Identify each change as exothermic or endothermic. So wood burning in a fire. Wood is what we're talking about, so it's exothermic, right? The energy is coming out of the wood. We feel that as heat coming out. How about ice melting? Endothermic. To melt the ice, you have to put energy into it to warm it up. So that's endothermic. How about water freezing into ice? Exothermic. Okay, that one's a little easier because we just talked about the opposite process, so that must be exo. Sometimes students have in their mind that an exothermic reaction gives off heat. Okay, and so when we talk about wood burning, or what about natural gas burning, is that exothermic or endothermic? That's exothermic. The ones where heat is given off, they get hot, that's easy to understand. Something like water freezing, how is that exothermic? Well, you have to take energy out of the water and make it colder in order to freeze it. Okay? So you have to kind of think about the perspective of the ice, the perspective of the wood. Any questions?